We've been looking at counting methods, and in this video we're going to look at a special case of the basic counting principle called a permutation. A permutation is the situation in which the order does matter that we're selecting these items and putting them in, and also that there is no repetition, or if you're choosing out of a bag, you're not replacing. So order matters, no replacement, no repetition. That's a permutation. Here will be an example. 6 comics are to perform at a competition. How many different ways are there to schedule them? Well, there's a key word there, schedule. So that means the order does matter if I'm putting them on a schedule. So I have 6 and then 5 and then 4, 3, 2, 1 options because there's no repeat. So each one, it goes down in what my possibilities are for scheduling them. So in this case, I'd have 720 different ways to schedule these 6 comics. Similarly, if I was going to award first, second, third place to the comics at this competition, the order does matter. And I have 6 possibilities for the first, but then only 5 for the second place, and then only 4 for the third place. So I'm down to 120 possibilities for awarding them first, second, and third. We do use some kind of fancy notation for permutations. In that second case here, I chose 3 out of the 6, so that was a permutation of 6 things taken 3 at a time. In general, if you have the permutation of n things taken r at a time, the n and the r are subscripts with a capital P. That's found by taking n factorial divided by the quantity of n minus r factorial. Let me show you an example here what that means. The notation can look a little scary, but it's really not that bad. So the permutation of 5 things taken 3 at a time, 5 factorial on the top, divided by the quantity of 5 minus 3 factorial on the bottom. Well, we'll simplify the bottom. That'll be 2 factorial. So 5 factorial, 5, 4, 3, 2, 1, multiply together. 2 factorial, 2 times 1. Cancel the like factors, and we come up with an answer of 60. All right, that's how we would use this notation. That's simple. So here's another example. A corporation has 7 members on its board of directors. We want to know in how many different ways can it elect a president, a vice president, a secretary, and a treasurer. Well, obviously there's no repeats because you're not going to hold, in most cases, 2 offices at the same time. So there's no repeats. And further, it does matter, which I can choose the same 4 people, but put them in different positions. So the order does matter here. So we are talking about the permutation of 7 things taken 4 at a time. Following our formula, that would put 7 factorial on the top over the 7 minus 4 quantity factorial on the bottom. So that's 3 factorial. Now notice what I did on the top. I did 7, 6, 5, 4, 3 factorial. I didn't keep writing it out because on the bottom I already had 3 factorial and I knew they were all going to cancel. So why write it all out? My answer here would be 840. Here's another one. Suppose you saw 20 movies during the year. In how many ways can you choose and rank the best 3? Well, that's 20 movies. You're picking 3. Permutations of 20 things taken 3 at a time, 20 factorial over the 20 minus 3 quantity factorial, which is 17 factorial. But on the top, we'll just go 20 times 19 times 18 times 17 factorial because that's going to cancel with the bottom. And then we just have to multiply those numbers on top to get 6,840. Now, depending on what kind of calculator you have, you should be able to do this with your calculator. I'm going to show you with an online Desmos calculator. You can't use this for testing, but it's still kind of a neat little thing here. Let me go back to it. There we go. Okay, so it's got these little NPR and NCR buttons at the bottom. That's our permutations and combinations that we'll talk about in another video. So if I click on this button, it's going to open a parenthesis and say, okay, how many things taken how many at a time? So I'm going to go back to the main menu and say, well, I want, this last one was 20, and then comma, 3 at a time, and I'm going to hit, enter, and I can't see it because my screen's too small.